Okay, students, very good morning to all. Okay, in this session, just we are going to discuss about the voltage source, current source, conversion of the current source to voltage source, conversion of the voltage source to current, current to voltage source. Okay, that we are going to discuss. Okay, so first, what is mean by Shruti? Okay, so we have to know what is the known to unknown values. Okay, so we have learned that the driving force. Okay, so which are driving force is established current through the current. So if the conductor is there, so we need the some force to move the electrons, okay, in the conductor. Okay, so what force is called? That is the we are calling as the some force we need. Okay, that for driving force is called as the electromotive force. That is the EMF or potential. So a device is a capable of the providing this force. Okay, it's called as in the voltage source. So whatever the force which is tries to move the electrons in the conductor, so that force we will call as the so force may be called in the voltage source. Okay, suppose we'll having the battery. So battery is a source which is give the voltage, right? So if the conductor is current, the electrons will be flow. That's the current will be flow through the conductor. So here, what are the types of the voltage sources? Okay, so ideal voltage source and non-ideal voltage source. Okay, so let me discuss about the detail what is meant by ideal voltage source. Okay, so it is the voltage source or generator whose output voltage remains absolutely constant whatever the changes the load. Okay, so if the that means if the load, if you suppose if we consider the load which is having, okay, so suppose if it's the resistor if we connected to the source. Okay, so if the volt resistors is the variable resistor, if increasing the resistance also, okay, if the increasing resistance means if increasing the load current, but the voltage source, okay, the voltage remains constant. Okay, whatever the voltage, if it remain constant, that is the ideal voltage source. Okay, so such a voltage source must possess the zero internal resistance. Okay, so every voltage source will practically they're having the some internal resistance. Okay, so resistance nothing but the opposing force. Okay, central resistance, so that should be having the zero. Such a voltage source must possess the zero internal resistance. Okay, so that internal voltage drop is the zero. So thus output voltage provided by it remain unchanged or calm. Okay, so in the practically it is the having this every voltage source having some internal voltage drop. Okay, due to that the voltage will be there. But in ideal voltage source, okay, so if the load is if area also, the voltage will be constant. Okay, and the internal should having the zero resistance. So here, however, such a ideal voltage cannot be obtained in the practical. Okay, so practically it is not answer. Okay, so but smaller internal resistance of the voltage source closer to comes in the ideal. But if they are having the lower voltage source, okay, so lower internal resistance, okay, that will consider that is the ideal voltage source. Okay, so here is the example. Here we are having the resistor. Okay, so here having the variable resistor, so this means variable resistor having the load. Okay, so if this is the voltage source, okay, so that internal resistance, okay, voltage or internal resistance, that we are indicating the resistor. Okay, so having the 0.005 ohms. Okay, and here there are the two cases. So when is the supplying the no current at no load, so here it's supplying the current. Okay, so the two cases come. So here let's see the diagram. So if the supplies the current, okay, they're having this sum two cases. So when it's supplying the at no current, okay, that is a at no load, that is the voltage is the 6 volts. If the when is supplying the load of the 100 amperes, okay, so the internal drop, that is a 100 into, okay, so so v equal to IR, this is the I. Okay, so here we're having the I and we're having the So we are having this is the I value. Okay, here having the resistor. Okay, so V is equal to IR, right? So we are drop is equal to IR. Okay, so that we are 0.5 volts. Okay, so hence voltage. Okay, so we are having the that is the drop. Okay, so output that will get the 5.5 volts. Okay, so this is the two cases. So the voltage drop. Okay, so when categorized, okay, so categorization, so here drop is the 0.5 volts is take place. That is when it's connected to the load, so they are having getting only, so only 5.5 only. Okay, 0.5 volts is dropping. Okay, so if the output is varies from that's 5.2 volt, that is it is not giving the voltage, that is a 6 volts. So here is so considering the constant compared to the wide variation. Okay, so 0 amperes to 100 amp. So if the where is the load current, that 0 amperes to 100 amperes, that is the drop. Okay, so we are getting the drop, that is a 0.5 volt drop is getting. Okay, so it may be treated. Okay, at this situation it may be treated as the ideal source. Okay, ideal voltage source. So when there is a large variation, okay, if the large variation output voltage, okay, small or moderate in change, so such a voltage may called as a non-ideal voltage or real type voltage source. Okay, so internal resistance. So in other words, the internal resistance of the such voltage source will not be 0 or small value. Okay, so rather it will be having the high value. So in the previous they are having the 0.05 ohms. Okay, so if it is having the 5 ohm internal resistance, okay, then it is a non-ideal voltage source. Okay, so here we are having the next, we are going to deal with the what is meant by ideal current source, what is meant by non-ideal current source. Okay, difference between the ideal and real current sources. So here the we have to know the driving force is of the current through the conductor. Okay, so that driving force will call as the EMF or the potential. Okay, so we have this. So types of sources: voltage source, current source. So in the current source, so it is the voltage source or generator whose internal resistance is having the infinity. Okay, so current source having the that it is the voltage source or generator whose internal resistance is a infinity. Okay, such a source must possess a very high internal resistance, okay, as compared to that the external. Okay, so if the external having the 5 ohms, so it will having the 50 ohms. Okay, at that time it is at the current source. Okay, that output provided by it remain unchanged or constant. Okay, so here we dig. So it is the voltage source or generator whose internal resistance is infinity. So if it's a battery is having the, so in the previous that is a 0.05. Okay, so here we are doing that is the having the infinity. Okay, so such sources will called as the current sources. Okay, so the output current provided it remained unchanged or constant. Okay, so cannot win. Okay, so however the ideal current source cannot obtained in the practice. Okay, so in the practically, okay, the voltage source, current source are not obtained. Okay, so but higher the internal resistance of the voltage source or closer come to the ideal current source. Okay, so similarly in the voltage source there is a smaller value. Okay, here is the higher value. Okay, so here are the example, here having the, so here having the 6 volts battery we having and internal resistance is the 1 mega ohm. Okay, so having the resistor. Okay, at that time here what will happen, so assume the load is resistance. Okay, this is the load resistance, we're having the varies from 20k to 200 k. K is nothing but kilo, 20 kilo ohms to 200 kilo ohms, that is 20,000 to 200,000. Okay, kilo ohms. So here is the internal resistance, that is the 1 mega ohm. So 1 mega into that is 1 into 10 to the power of 6. Okay, if the here we are having the two cases we'll get. Okay, so at first case here is the when it's supplying the current to the 20k. Okay, so at the it having the at first it having the 20k, so the current will flow, that is the 5.9 microamperes. Okay, so it's the V. Okay, so resistor. Okay, so so in the voltage source we are taking the V equal to IR. Okay, so at voltage source we are taking the V equal to IR. Okay, here I is equal to V by R. So voltage is 6 and resistance that we have taken. Okay, so here we're getting the 5.9 microamperes. Okay, next here is this system. So 200k. So we'll getting the that I equal to V by, so resistance V. Okay, and this resistance. Okay, then we'll get the current flowing in the circuit. Okay, that is the 5 microamperes. So here we can say, so from this out, so here the change in current, that is a 0.9 microamperes is take place the when load resistance is increased the 10 times, that's the 220 kilo ohms to 200 kilo ohms. Okay, so having change is only 0.9 microamperes only. Okay, so the output current, that's the 5.9 to 5 microamperes can be considered, it's a constant as compared to the wide variation in the load. Okay, if the if at that time, okay, so if the 20 to 200k, that is the wide variation. Okay, so if the less variation in the current, okay, so it is called as a ideal current source. Okay, so it can serve as a ideal current source. So if the large variation, okay, so when is the large variation, the output current for the small or moderate variation. Okay, so suppose if the resistor it varied from 20 kilo ohms to 22 kilo ohms, but it is varied to 5.9 microamperes to 5 microamperes in this situation. Okay, at this situation it's called as a non-ideal current source. Okay, so it will internalize in such a current source will infinite. Okay, not infinite or higher value. Okay, rather than the smaller rest. Okay, then it is called as the non-ideal current sources. Okay, so there having the we are having the conversion of the currents voltage source to current source. Okay, so if wanted to at the, okay, solving the problems we have to convert, that is the voltage source to current source. Okay, so at this situation, so we can say, so in the voltage source the current, okay, the current source will having this one. Okay, so voltage source to current source, so voltage source is series with the resistor. Okay, so in current source the resistance is parallel with that. Okay, so voltage source in the will having the in series. Okay, in current source having the, that is having the in shed. Okay, that is the parallel with the source. Okay, so AC. Okay, so that is a voltage source will indicate there. Okay, current source will indicate the this signal. Okay, so this is called as a source conversion technique. Okay, it is useful when network the theorem. Okay, so when solving the problems, so if the current source is there, okay, so if want to convert that current source T voltage source, then we'll kill the, that is the in series with this one. Okay, they will having the some problems also there. So this is about the voltage source current source problem. Okay, so this is the total of the, okay, so end of the DC circuit.